plus 2 cross. First integral technique is substitution method. What are you gonna do with the substitution method? First thing is identify when substitution method will simplify the integration. So that's very important. You have to identify when substitution method is working. Second is use a change of variable to make integrals easier. That's why we're using substitution method. Third one is return to the original variable or adjust upper limit, lower limit. Let's get started substitution method. First, we're gonna use substitution method for indefinite integral. Here is a form of indefinite integral. So how gonna use the substitution method? Look at this one, fg of x, g prime x dx. That's the idea. So this one is, what are you gonna substitute here, guys? First substitute inside the function of f of x. That's gonna be u. G of x gonna be u. Then we're gonna looking for u prime. That's gonna be u prime. That's gonna be du equals g prime x dx. That's you have looking for when you do substitution method. So that part gonna be du. Then you're gonna use the substitution method. Here's very important, guys. First, you find the u. Then you're gonna find the du gonna be in there. The integrand is not. We cannot using substitution method. After you replace u du, you're gonna see new indefinite integral. So indefinite integral f of u du, this is a function of u. Now you see f of u, this is indefinite integral. First thing you have to find the antiderivative of f of u. So you find the antiderivative f of u. Now you find indefinite integral of this. But very careful about substitution method. After you find the antiderivative, you have plugging back u value. U equal g of x. Now you plug in u equal g of x in antiderivative of u. Here is right there. U plugging back g of x there. Now you find indefinite integral for this one. So answer gonna be f g of x plus c, because original form is function of x. The final answer gonna be function of x, not function of u. So let's have example of substitution method for indefinite integral. So first one is, we're gonna evaluate this function. We wanna find indefinite integral. First one is you have to find what is gonna be u. So first thing is you're gonna start with what is gonna be u. U gonna be x squared plus 1. Why? Because du gonna be 2x dx right there. 2x dx right there. That's gonna be du. So now, after you identify u, you find the du, you're gonna substitute. So you have a new form of integral. Integral u fifth power du. So now you're gonna find this indefinite integral by using power rule. Power rule say power is 5. I'm gonna find the antiderivative. So here is power rule. Power is 5. You add 1. 5 plus 1 is denominator. Power gonna be 5 plus 1 gonna be 6. So you have u6 power over 6 plus c. Now, you find the function of u. You're gonna plug in back to u value right there. You're gonna be 2x squared plus 1. No, I'm sorry, x squared plus 1. You're gonna plug in back right there. So you're gonna be x squared plus 1. So final answer gonna be x squared plus 1 over 6 plus c. So main idea is this gonna be substitution method. We have to use or not. After you decide, you're gonna decide what is gonna be u. That's the main concept of substitution method. For example, integral square root of x 2x minus 1 dx. So we definitely use substitution methods for this indefinite integral. First, when you see this indefinite integral, first you have to find the u. What is gonna be u? Can you guess? So u gonna be inside the square root. So you're gonna be 2x minus 1. After you finding u, after you find the u, what is gonna be du? Du gonna be 2dx. Here is a very tricky part, but you cannot see 2 right there, only dx right here, guys. So you find the dx gonna be right here. So we have to find the dx gonna be divide by 2 both sides and 1 over 2 du. So that's dx gonna be replaced with 1 over 2 du. Okay, so now you have integral square root to u 1 over 2 du. So 1 over 2 is constant. That's gonna be taken out in front of integration. So that's gonna be 1 over 2 integral square root to u du. So we practiced previous session, but let's review one more time. 1 over 2 integral u of 1 over 2. 1 over 2 is a power. How can find this antiderivative, guys? So power is 1 over 2 plus 1. Denominator is the same. That's gonna be 1 over 2 times u 3 over 2 over 3 over 2. 2 times 3 over 2 gonna be 3. Numerator gonna be u2 over 3 plus c. Now, remember that this substitution method, you always have to plug in back. You're gonna be 2x minus 1, then you're gonna plug in back there. So answer gonna be 2x minus 1, 3 over 2 over 3 plus c. Now, what are you gonna do next one? So now we're gonna using substitution method for definite integral. This one is a little tricky compared to indefinite integral. First, the same thing, we're gonna do same thing for integrand. So when you see this one, first one is, guys, inside the function gonna be u equals g of x. You find the du, that's gonna be g prime x dx. That's gonna be du we're finding. Now, next step is you change the limits. First one is you're gonna change a. X equal A, you gonna be G of A. That's the first thing you have to do for the limits. Upper limit, that's gonna be B. So BX equal B, you gonna be G of B. Now, you using substitution method for definite integral, you're gonna substitute everything for this integration. So for here, right there, guys, you substitute everything. Low limit g of a, upper limit g of b, function gonna be f of u du. Now, we're gonna do definite integral by use fundamental theorem. So you're gonna find antiderivative after f of u, you plug in the boundary. That's we're gonna use substitution method for definite integral. Let's give some example for definite integral. So first, let's do the definite integral by using substitution method. Integral 0 and 1 e to the 4x dx, right, guys? When you see this one, you knew this one is gonna be used by substitution method. Why? Why you have to use any substitution method? Because the power of e gonna be 4x. So 4x gonna be u, guys, u equal 4x. That's gonna be substitute. Then you're gonna substitute dx too, right? So first you find the du equal 4dx. So dx gonna be 1 of 4 du. So dx gonna be replaced with 1 of 4 du. Now, lower limit first, guys, okay? So lower limit is x equals 0. So which meaning is x equals 0, u equals 4x. You plug in x equals 0, 4 times 0 is 0. That's you're gonna replace with 0. Upper limit is 1. X equal 1, u equal 4 times 1. That's gonna be 4. That's replaced with 4. Now, let's rewrite this integration. What is gonna be? 0 and 4 e to the u times 1 over 4 du. The 1 over 4 is constant. Plug in out. Take it out in front of integration. 1 over 4 integral 0 and 4 EU du. So can you find the antiderivative e to the u? Yes, you can. Antiderivative e to the u is e to the u. So now we're gonna find this definite integral. 1 over 4 e to the u, 0 and 4. So that's gonna be 1 over 4. Plug in the 4, plug in the 0. That's e to the 4 minus e to the 0. E to the 0 is 1. That's replaced right there. We have 1 over 4 e to the 4 minus 1. Guys, very clear about substitution method for definite integral, I hope. So let's do one more example right here. So integral 0 into x, 1 over x squared dx. So can you identify what is gonna be u there, everyone? So you're gonna be denominator 1 plus x squared. So that's gonna be u, guys. What is du? du is 2x dx. So there is no 2 is right here, guys. So you divide by 2 both sides. You find x dx. That's gonna be 1 over 2 du. So let's replace the lower limit. X equals 0 gonna be u equal x squared. 0 squared plus 1 is 1. Upper limit x equal 2. That's u gonna be 2 squared plus 1. 4 plus 1, that's 5. So I can replace everything here by using substitution method. Can you see integral 1 over 5, 1 over u times 1 over 2 du. That's you find right there. So 1 over 2 is outside. You see integral 1 over 5, 1 over u du. Now, can you find the antiderivative 1 over u? That's you find it, ln u plus c. So you find the antiderivative 1 over u, then you're going to use fundamental theorem. That's going to be 1 over 2 ln u, where to where? 1 to 5. When you plug in the 5 and 1 right there, 1 over 2 ln 5 minus ln 1. Guys, remember ln 1 gonna be 0. That's gonna be replaced by 0. So we have final answer ln 5 over 2. That's how to use substitution method for the definite integral. Now, what do you learn from substitution method? What is the key takeaways? First, you have recognized a pattern where substitution method is effective. So how do we recognize? First, you're gonna see the integrand. Can you find the antiderivative quickly, or can you find the antiderivative from the definite indefinite integral formula? It's not. You're gonna think about substitution method. After you identify substitution method, you're gonna find du and du. You're gonna replace in the integrand. That you have to do it. After that, indefinite integral, you have to return the x after integration. That's very important because you're gonna be replaced by x. So you're gonna plug in back x after integration. But definite integral, you're gonna adjust the limit and find value by using the first fundamental theorem.